You don't need a weapon when your body itself is the weapon. Some creatures are living arsenals. The Bombardier Beetle, known as Brochinus, is a tiny insect with one of the most advanced chemical defense systems in nature. Inside its abdomen are two separate chambers. One stores hydroquinone and hydrogen peroxide. The other contains powerful enzymes. When the beetle senses danger, it opens a valve between the chambers. The chemicals instantly react, releasing heat and oxygen. In less than a second, the temperature of the mixture rises close to 100 degrees Celsius. Pressure rapidly builds inside the abdomen, forcing the boiling liquid outward as a precise defensive spray aimed directly at the attacker. The beetle can rotate this biological turret almost 360 degrees and fire several bursts in rapid succession. This adaptation helps the bombardier beetle survive against birds, frogs, spiders, and predatory insects. The hot chemical blast burns and repels predators, giving the beetle enough time to escape. Evolution transformed this tiny insect into a living chemical weapon built entirely for survival.
The platypus, known as Ornithorhynchus enaeus, is one of the strangest mammals on Earth. It combines traits of mammals, birds, and reptiles into a single animal. But one of its most unusual features is hidden on its back legs. Male platypuses possess sharp, venomous spurs connected to specialized glands. The venom contains proteins capable of causing intense pain, swelling, and temporary paralysis. Unlike the venom of many snakes, platypus venom is rarely lethal. Instead, it produces such extreme pain that the victim can lose the ability to hunt or defend itself for long periods of time. This becomes especially important during the breeding season, when males fight each other for territory and access to mates. The platypus evolved in the cold rivers of Australia and Tasmania, where survival depends on specialized adaptations. Its dense, waterproof fur protects it from freezing water, while electroreceptors in its bill allow it to detect the tiny electrical signals produced by prey hidden underwater. The venomous spur became another evolutionary solution, a natural weapon designed for defense and competition in an environment where speed and strength alone were not enough for survival.
The electric eel, known as Electrophorus electricus, is not actually a true eel. It belongs to a group of South American fish called knifefish. But what makes this animal extraordinary is hidden inside its body. Nearly 80% of the electric eel's muscles have evolved into specialized electrical organs. These organs are made of thousands of modified muscle cells called electrocytes. By moving sodium and potassium ions across their membranes, the cells generate electrical voltage. When activated together, the eel can produce discharges reaching up to 600 volts. That is powerful enough to stun, paralyze, or even kill small fish and amphibians. The electric shock is not only a weapon for hunting, but also a defense against predators. The eel also produces weaker electrical pulses used for navigation and communication. In the dark, muddy waters of the Amazon, visibility is extremely limited. Instead of relying on sight, the eel senses disturbances in its electric field to detect nearby objects and prey. Life in oxygen-poor rivers forced the electric eel to evolve into a living biological generator. Evolution transformed its muscle tissue into a natural battery powerful enough to provide both survival and food in one of the harshest aquatic environments on Earth.
The porcupine, a mammal from the families Hystricadae and Erythozontidae, carries one of the most effective defensive systems in the animal world. Its body is covered with nearly 30,000 quills. Each quill is actually a modified hair reinforced with keratin and tipped with microscopic backwards-facing barbs. When a predator makes contact, the quills detach easily from the porcupine's skin and remain embedded in the attacker. Despite a common myth, porcupines cannot shoot their quills. Instead, they defend themselves by turning their bodies or striking with their tails, driving the sharp quills deep into the predator's muscles. The tiny barbs make the quills extremely difficult to remove. As the predator moves, the quills can continue pushing deeper into tissue, causing infections, severe pain, and long-term injuries. This defense is especially effective against large predators such as lions, leopards, and wolves. The porcupine does not rely on speed, strength, or camouflage to survive. Its evolutionary strategy is simple but powerful. Passive defense that transforms a single attack into a lasting and dangerous problem for the predator.
The archerfish, known as Tocotes chatteraeus, lives in the mangrove swamps of Southeast Asia. At first glance, it looks like an ordinary fish, but it possesses one of the most accurate hunting systems in the aquatic world. Using a specialized mouth and tongue structure, the archerfish can fire a thin jet of water at insects and spiders sitting on leaves above the surface. Some shots can reach distances of up to 2 meters. The real challenge is accuracy. Light bends when passing between water and air, distorting the position of the target. The archerfish automatically compensates for this optical illusion. It adjusts its aim depending on distance and angle, allowing it to hit prey with remarkable precision. One accurate shot is often enough to knock an insect directly into the water, where the fish quickly captures it. This adaptation allows the archerfish to survive in an environment where much of the available food exists outside the water itself. Evolution transformed this small fish into a living hydraulic weapon designed for precision hunting. Life is a constant race between shield and sword. Every creature we explored today demonstrates how evolution can transform weakness into strength. Thanks for watching. Subscribe for more.